Alright, in today's lesson we're going to be looking at exponents, and we got to go over a few definitions, and then we're going to learn about the product rule and quotient rule. So first, what is a power? And a power consists of a base and an exponent. So for example, if I had 5, well, we'd say to the power of 3. 5 would be my base, and 3 would be my exponent. Alright, next we have, what is an exponent? So it is a number that indicates how many times a number or expression is to be multiplied by itself. So for instance, in the example that we had above, we said, well, we had a base of 5 and we had an exponent of 3, and what that really means is that base is being multiplied to itself 3 times. That's how we have the 3 on top, right? We have 1, 2, and 3, and that's equal to 5 times 5 is 25, and times another 5 is 125. Now the last thing I want to talk about is touch base on that term that you've already heard me use, and it's base. So what is the base? And our formal definition is, it is the number that gets multiplied when using an exponent. So it was that 5 that we had. Now with all that being said, I think we're ready to actually express this expression using exponents. So we're basically going to create an exponent. We're not trying to solve it. What we're trying to do is just create an exponent based off of what we see occurring. So I'm going to do the first one, so follow along. For instance, I have 1, 2, 3 y's. So I have 3 y's being multiplied to each other. So that's y to the 3rd power. Now when it comes to the x's, I have 1, 2 x's. So that would be times x to the 2nd power. And that's how we would express this expression as an exponent. So y to the 3rd power times x to the 2nd power. Now I do want you to notice something that I did. Notice that I have the highest power first, and typically in mathematics, whenever we write an expression with variables or a mixture of variables and numbers, we want to make sure that we always put the highest power variable first. So notice I had the y to the 3rd power rather than having the x first. So just keep that in mind. I want you to do that as we're going through these problems. Next I have 7 times 7 times 7 times 7. So that's 4 7s. So this could be written as 7 to the 4th power. Alright, now on this next one, I have 1 5, 2 5s, 3, 4, and 5. So we actually have 5 5s. So we would have 5 to the 5th power. And when it comes to 9, we have 1, 2, 3 9s. So that would be times 9 to the 3rd power. And that would be our final answer. So we've just taken that and written it as an exponent. Put my multiplication sign in between. Alright, so now let's get to using this rule. So you've kind of seen how we could put exponents together, how we can create exponents, and you've learned the definitions you need to know: power, exponent, and base. So now let's use something called the product rule. So notice my question here is, it says, what is the product rule and how do you use it? Well, the way we use it is when multiplying monomials with the same base, you add the exponents. So let me show you what I'm talking about. My base is the x, right? That's my base. So I'm going to rewrite my base of x. My exponential power, in this case, is 8. And this one over here is a 12. Well, when we're multiplying exponents that have the same base, all we do is simply add the powers. So it's the power of 8 plus the power of 12. Now I'm going to draw a little line through it because that verifies that I have now put those into a problem and used them. And then we're going to simplify this as 8 plus 12, and that gives me 20. So my final answer is x to the power of 20. Let's look at this next one. Now this next one, notice we have a coefficient of 4 for a. So really that coefficient is just a multiplier, right? It's just being multiplied to a. So whenever you see one like this, I want you to write it out and think of it as actually 4 times a to the 4th power times a to the negative 2nd. And I think if you write it out, especially if you have multiple numbers, multiple variables, it's really helpful if you spread it out with those multiplication symbols so that you don't get mixed up. So now when this is done, what I want to do now is go ahead and we're going to multiply our same base exponents, right? And so that we can get our final answer. Now, I'm just going to bring down the 4. There's no other constants for me to multiply 4 to, so I'm just leaving it as 4. And then this a to the 4th, we have a to the 4th power. And this is a to the negative 2nd. So it's going to be plus the negative 2nd power. Now you will notice that I went ahead and put the negative 2 in parentheses. Anytime you have a negative power, always put it in parentheses. And there's a reason for that later on, but we're substituting a number, so I want you to do that. And now we're just going to go ahead and get our final answer. So we have 4 times a to the power of 4 plus negative 2. And if you were to put that in your calculator, that would 4 minus 2 is going to leave me with 2. So 4 times a to the 2nd power. And that's our final answer for that one. Now at this point, I want you to pause the video and try this third one on your own. But then after you do it and you think you got the right answer, hit play on the video and see what I got and compare it. So this is how we're going to solve this one. I'm going to rewrite it as 2 times y times x squared times 3 times x cubed times y to the 4th. So notice I got it all broken up and spread apart from each other. And now I'm going to see what things can I go ahead and multiply out. Now in this case, I do realize that I have a constant of 2 and a constant of 3. So I want to go ahead and multiply those out. So 2 times 3 gives me 6. Then if I go ahead and I look at this next one here, I actually have y. Now this y doesn't have a power, but that means that it's actually the power of 1. So I got y to the power of 1. And I notice I have another y over here to the power of 4. So I'm going to put plus the power of 4. Because they're the same base, we're adding the powers, power of 1 plus power of 4. Cross those out. And what I got left to deal with is the x to the power of 2. So x to the power of 2. And then we have times x to the power of 3. So I'm going to put plus 3. Now I just want to clean this up and make my answer look really nice. So I'm just going to bring down my 6, no change there. And then y to the power of 1 plus 4 gives me y to the power of 5. And then x to the power of 2 plus 3 is going to give me x to the power of 5. And I'm going to go ahead and box that, and that is my final answer.